Assalamualaikum and a very good afternoon. For today's lecture, we proceed with chapter 4, which is factors affecting the polymer chain structural differences. So we are going to cover what is the factors that will affect the polymer chain that compose of structural differences. But before that, let's see about the conformation. Conformation is the flexible or rigid type. So we use the term configuration and conformation to describe the geometrical structure of a polymer. So actually polymer properties are different from metal, ceramic, glass and so on because polymer composed of non-metallic element. So the chemical bonds in polymer are also different from those found in metal, ceramic, and glasses, and so on. So the most common element found in polymer is carbon. Let's see about configuration. So what is configuration? Why we use term configuration in polymer? Configuration is the order that is determined by chemical bond. So just like I mentioned just now, chemical bond in polymer are different from those found in metal, ceramic, and so on because it composed of non-metallic element. So configuration is the structure of the repeat units, which is fixed between the polymer. So this structure is fixed by the chemical bond between adjacent atoms. So the shape that created the polymer is known as the configuration. Let me give you a simple example, like a children toys, such as the building block. The children can design so many shapes by using the building block. So there can be also many different configuration for atoms of polymer of a particular type. So the configuration of a polymer cannot be altered unless chemical bonds are broken and reformed. For conformation, the order that arises from the rotation of molecules about the single bond. Okay, let's proceed with configuration. Okay, like I mentioned just now, configuration is the shape. Okay, the shape that create a polymer. For example of the configuration is isomerism. What is isomerism? Isomerism is polymer that have a different structure but have a same chemical formula, but the different in properties. The other meaning of isomerism, different molecular configurations for molecules of the same composition, means that it have a different shape, a different structure. Okay, so it have a same chemical formula or same composition with different properties. So different properties is affected by chemistry, the size, which is the molecular weight, the shape, the structure. Okay, so for the structure, isomerism is affected by the linear, branch, crosslink, or network polymer. For example, for linear butane and isobutane structure, their different physical properties are slightly different. Okay, their physical properties are slightly different. For example, isobutane, which has the central carbon atom, is linked to 3 adjacent carbon rather than 1 in linear, it will tend to have a different boiling point compared to linear structure. Okay, for isobutane, it will tend to increase the boiling point by 10 degrees Celsius, but otherwise they are very similar compound. Okay, for linear and branch, it is the isomeric state. So it can be either stereoisomer or geometrical isomer. So for stereoisomer, it can be divided into the stereoregular the structure, which is isostatic, syntactic, or astatic. For geometrical isomer, it can be categorized into two, which is cis and trans. So cis and trans, we will discuss more details in the other slide. Okay, cis trans isomer. The two types of polymer configuration are cis and trans. This structure cannot be changed by physical means, for example, the rotation. The cis configuration arises when substituent groups are on the same side of a carbon-carbon double bond. Look at the example here. This is the cis natural rubber, which is cis 1,4 polyisoprene structure. We can see the structure. We have CH2 group, bulky group here, which is on the same side. So this is the natural rubber cis 1,4 polyisoprene structure. This is the full version of the structure, natural rubber cis 1,4 polyisoprene, which has a less symmetrical structure that does not allow easy crystallization. So when the bulky side group on the same side, it will tend to produce an amorphous polymer. While for trans refers to the substituent on opposite side of the double bond. This is the side which is the bulky side of trans 1,4 polyisoprene. Okay, it is in the opposite side. So trans 1,4 polyisoprene, which have regular structure that allows crystallizations. As a result, trans 1,4 polyisoprene, also known as gutta percha, is hard and rigid. So, trans 1,4 polyisoprene is crystalline polymer. Configuration cannot be altered unless if we want to alter, we need to change, we need to break the bonds. Okay, what is stereoisomerism? Okay, we look at this first, isomeric state. Isomeric state can be divided into stereoisomers and geometrical isomers. What is stereoisomers? Okay, first, final types of isomer. Here, isomer variation occur as a result of three-dimensional structure of some polymer. Okay, so it is possible because 4 adjacent carbon atom, which is like carbon, can exist in two different forms when the subsidiary group or atom attached to the carbon are all different. So the carbon atom, known as asymmetric carbon atom, a very simple example of phenomenon is the structure of this structure A, B, C, D. So it can exist in two different forms, which is the rotation of B, E and D like this, or it can be B, D and E at the left side, at the right side or at the left side. Okay. So it can exist in two forms which are mirror image. So the line here is the mirror plane or mirror image of one another. Okay, one of the two possible compounds shown here is the example of stereoisomerism in a small molecule. So it is a feature which is these two polymer share same number of molecule as well as the polymer. Okay. Okay, stereoisomerism can be divided into isostatic, syntactic, and atactic. For example, if we have a vinyl polymer, which is polymer with a double bond, to which is attached the pendant side group. Okay, so for example, like this polymer, this is the side group in every alternate carbon atom in the main chain. So it will give rise to the tacticity. This is tacticity. So when the zigzag chain is written with the plane of the chain in the plane of the paper, there are three ways in which the position of the pendant side group can exist. So the methyl groups in polypropylene, for example, polypropylene, it can occur on one side, which is isotactic, and alternate side, which is syntactic, or placed at the random, which is a tactic form. So these possibilities will affect the properties of the polymer because isotactic and syntactic PP have the order structure, both have a crystalline structure, but atactic chain are quite irregular and cannot be crystallized. So isotactic PP is the common form of the commercial material, isotactic PP. Although atactic PP, it is used as a binder for paper, for example. Okay, for syntactic PP has recently become available commercially, being made using a new family of catalysts known as metallosense catalysts. Okay, for geometrical isomers, like I discussed or I explained in the cis or trans of polyisoprene. Okay, for example, cis polyisoprene, which is in natural rubber, it characterized by highly elasticity and low internal friction. For trans polyisoprene, also known as gutta-percha, behave as hard plastic and more easily to crystallize. Catalysts can alter the structure of cis-trans. For example, aluminium-titanium ratio. If aluminium-titanium more than 1, 95% cis polyisoprene is formed. If aluminium combination with titanium less than 1, 95% trans polyisoprene can be formed. The polymerization of isoprene to natural rubber is highly organized and controlled process which result in one 4-cis product. In certain type of plant, isoprene gets polymerized to give gutta-percha.